Okay, we'll extract today this result, updated data. So use database, table name. This is the row 0110. Now, how this data will flow? What is the pipeline? Pipeline will be, I will extract this data only, which we have updated. This is RDBMS. RDBMS. After RDBMS, scoop is there. Scoop is writing this data to HDFS directory. In HDFS, I will create one directory, and in this directory, I will store that data, one row or whatever result we have updated from here. Okay. Once this is stored, then we will run Hive script, and within this Hive, I will perform so that Hive script, HQL script is having 7 different stages. There I'm performing CDC, changing data capture. Whatever data is changed, okay, whatever data we have changed here as in this row, this information will go to one table. So we'll create one table here in Hive, and this table will point this directory. In Hive, we will create one more table, and that table we call a staging table. Staging table. Okay. So in a staging table, we will point to this directory, and then Hive has managed that data in a table. We can run a query directly there. In Hive script itself, we are using now SCD type 2 technique, which will, so first this CDC will do, it will extract, it will communicate from this table, because now we have got two tables. One is a staging table and second one is a main table. One is a staging table and second one is a main table, right? Main table has all the result, all this row is available. Staging table has just this result, and this result is already present in Hive main table. Okay, so we will try to communicate from this table to this table using the insert operation. We will use binary comparison as a part of CDC. We'll check this data is present here in this table or not. If this result is already present in this table, we will make that result as non-active, as an inactive. We'll set their flag as N, and this new data will go and store in this main table, which will have flag as Y. So when I see Y and N, I will know which one is a previous or old record and which one is a new record. Okay, so this flow we are running in CDC and SCD type 2. SCD type 2 is just doing one thing extra. It is maintaining the history also. So it's not deleting that. And there are SCD type 1, type 3 also, but type 1 does not maintain the history. They delete the history and take the new result. And all this two process we will check in our Hive scripting. So let's go and see the script first, then we will run it. pwd user tmp, and here we'll open in user tmp, we will open this script, etl job custom dot assets. From line number 11, line number 11 is using source user tmp parameter.txt. Inside parameter.txt, we have all the schema stored. ETL data schema, this is hive schema, which is FIU. Scoop job, this is we have not yet seen. We'll create one job here now. We'll create one scoop job. In a scoop, we have seen how to create a scoop job. So this scoop job is stored in my um, my TMP folder. Inside this TMP folder, we'll see in a while. Okay, inside this parameter.txt, we have a scoop job. Hive script. This Hive script is also stored in this parameter.txt. Now we are using echo to print this. Q is a dev environment. Now we'll check this scoop job first. What is this job and what this job will do? Then we'll start from line number 31. I'll open one more cell. And here cd user tmp. I will open parameter.txt first. In parameter.txt, check scoop job, cust scoop job. Okay. And in Hive script, we have this script. So first, what is a cust scoop job? Now for data extraction, when we are extracting data from here, how it will extract? What is the query which will run from a scoop and connect with the RDBMS and HDFS? That query is as follows. It is so I'm writing a query for update. Okay, this is a update extraction query. Update record extraction query would be the fairest statement. And in scoop space import hyphen connect. So we are importing it because connect, this is a connection URL, JDBC MySQL IP address / database name, username, username is root, password, then table name we know dim customer, after table name 3 arguments we will pass, hyphen incremental will have last modified as argument, then hyphen check column, check hyphen, I'm continuing with this in the next line, check, there's no space. Okay, check column. Which column you have to pass? Load date column, because for update you must need a date column. Condition will work only in this. Column is load date, right here, load date, then hyphen last value. Last value will have this value 2020/04/22/11/09/51, because when you update this, your time is continuously running, right? If you think from the clock perspective, this is a clock. This is continuously moving in a clock direction, a clockwise direction, right? So when this is continuously moving, suppose if I do any operation 8, 11, 10, 15 am, and if I start extracting the data, so time after extraction, suppose I'm after 5 seconds I'm extracting, so after 5 seconds means 11, 10, 20 am, this is my extraction time. What they do, the query will check this time as a lower bound and my system time as a upper bound. Remember, lower bound and upper bound. So system will take this date and this date, and whatever result is coming including this time and this time, all the data will extract and store in my system, which is HDFS. That's why we give this time. Okay. So if there are 5 result updated during 11/9, yesterday we updated this, right? So uh, that date, and 1 second, we did not update the load date here. So we'll have to update the load date also. Okay, I'll run one more query to update this. So this will be updated. Yesterday we forgot to update this also. Whenever we change this, by default, your load date we set as, and it will change also. So this load date we will change. Now this load date will check from my system and this date, and whatever result is coming, it will write it in target directory. Target directory. In this target directory, I'm giving dim cust number of mapper 1. This is a whole query. So before going anywhere, we will update this. Cust, I'll not change the value, I'll change the load date only. Load date is equal to now, where customer ID is 11. Okay, this is today date, 28 July, 10, 20, 30. HHMMSS. I'll give this time. This will highlight 2020 07 28 10 20 and 13. But the question is, this is one table, I'm running one query, and when we started observing our project, we said there are 120 table. So if every day 120 table is updating and there are so many results updating, then if I'm writing this query, then this is a manual process, right? What I'll do, I'll create a job. So this query, I'll not write manually in the script. I will create one job. I will assign this job to one variable, and I'll pass that variable directly to my script. So automatically this query will run and data will extracted and stored in my table. So we often create this job one by one. Will never do. And I'm going to create one job for this query. Okay. Here, this is the same cust scoop job. So my job name will be cust scoop job, because this scoop job in my script and this scoop job are same. So whenever this is exported, export, this is an variable or an argument. So this is scoop job will take cust scoop job, and cust scoop job we will write inside a job. So for that we will open prior setup now again, colon q, prior setup, this file. Inside prior setup, stage number first, this is for scoop job only. We have seen this in scoop. Copy this and open one cell. and paste it here. Scoop job, cust scoop job. So I'm formatting it first. Slash means new line. Okay. So if you want to write a new line, we give slash. And this is my query. Scoop job, create cust scoop job will verify again. This cust scoop job, the same job uh, defined inside this scoop job, line number 13 in my cell. Then hyphen space import, hyphen space import. Till this part you'll have to write only for scoop job, and rest from this import till last is the same thing which I have written this, right? So import hyphen connect JDBC MySQL. I'll change the IP address 41.1, database name of RDBMS, which is PRWA, username root, password root, table name, target directory. We'll check this target directory is present already or not in HDFS. HDFS DFS -ls slash. There's no big data directory. Then this, okay. Check column, load date, merge key. Merge key, I will not use this for now. Okay, merge key has a separate case. So merge key is one argument in the scoop. When to use merge key, we'll see once this is run. Incremental last modified last value. What is the last value? So last value is this date 2020, right? 2020. We read this within double quote 2020 07 28 07 28 10 20 13 10 20 13 as text file. No need to give this because by default it will store in a text file format only. Number of mapper hyphen m, and 2 if I have any primary key. So we can check in this table, do we have any primary key for dim customer? Desk and dim customer. And we have primary key here available as customer ID. So 2 number of mapper will work, but I have just one data chain, so no need to use 2 mapper. If there are multiple results, then we can increase, decrease the number. This is the query. I'll copy this query and paste here. You can paste it anywhere. Job will be stored and saved. Right click, paste. When we copy this, special characters will change because encoding is different, and rest all is good. Enter. This will take some time. We are creating currently a job. This is the job creation stage, and check job is created or not. Scope job hyphen list. This is a cust scope job. Okay. Now job is created. Exit. Stage number 1 is done. And when this data is stored in big data project batch 1, we'll go back to this flow again. Hive data, a Hive table will point to this directory, and this is the same directory, big data batch 1, right? So big data batch. I will write the exact name. This is big data project batch 1. Big data project batch 1. In this directory, that one result will go. This result will go. In Hive, we will create one more table, which is the staging table. The main table is already created. We'll go and create this staging table now. Stage number 4. Sorry, stage number 2. First, I'll copy this and paste in my text field here. When you check this query, it's a simple DDL. And what we are doing in this DDL, let's see. In this DDL, we said create external table. Why external table? Because external table can point to the directory which is not maintained by Hive internally. We are maintaining that. That's why external table, not internal table. The question comes like that. So customer dim stage 1, this is my table name. This is all the column from RDBMS only. And one thing is interesting here, that the location. That's what I said here. In your Hive point, where you're pointing, where your Hive table is pointing, your Hive table is pointing to a directory which is holding this data. So automatically this data will populate in a staging table. This result will automatically populate in a staging table. So we go now and create a staging table. Copy and paste. We'll create this inside FIU directory only. And prior setup task is I can done from here. Sudo hive so databases user file then semicolon. Whenever data will come, automatically this will point. So tables. So I have created one directory, one fixed directory, and I have created one table that whatever inserted updated result will come, it will store in this directory and automatically it will be populated in my staging table. So two tables we have created, one main table, one staging table. Okay, or earlier we used to call it a flat table. So in between in between transaction, we have flat and main. So always flat is giving. Today we call it staging. Staging is giving that information to main table. Table is created. We'll minimize this. And now, what is this Hive script doing? Okay, so when my query will run, so I think let's run the query first. Let's see the output, and then we will go to check this Hive script. In this scoop script, we are not doing much. We are running scoop job first. So we said if any directory is already present, delete it. If not present, then do not delete it. There's two conditions we have given. If else, if it is present, it will delete. And next is scoop job. This is the scoop job execution. In terminal, whenever we create a scoop job, this is the operation hyphen exec stands for execution. This scoop job is having cust scoop job. When they succeeded, they will give us acknowledgement. This is completed. Otherwise, we get failed again. After the scoop, Hive script is running, and we are going to see this script after job. So one script is pending, Hive script. Okay, no need to change anything here. All good, because already we have created a job. Then my staging table is created, main table is already there. We change on this script. Time to run this. sh space etl underscore job first dim dot sh. As I said, this is one time script, and this is a daily script. If why I'm calling daily, because daily we are doing some update and insert. But one time complete data extraction, this is one time activity. If I've extracted 120 table, all the result I'm not running again and again. This data is already present in my tables because this is a full snapshot. No condition is there. Now submit this, and we'll check the log file. So there is no directory. That's why we get no such file or directory. When they're trying to run a scoop job, it is asking password. For security, we'll give root as password. This got failed. Merge key or append is required using incremental last modified the output directory exist. Okay, so I think I will have to write merge key also. Delete scoop job, because job we cannot edit. That's why I need to delete this job and recreate with merge key. Copy, paste. Hyphen merge key. Column name, customer ID. I'll tell you what is merge key. Okay, that's right. Customer ID. Copy, Enter. Some exception. Incremental last modified last value. Check column. Let me open branch setup again. cd user tmp. Incremental. Okay, incremental does not have hyphen. That's a one error. Then it's text file. The rest is fine. So I think it failed because of incremental option, not because of merge key option earlier. Enter. Job is created. Well, list again. Scoop job hyphen list. Then, so problem was with incremental was not defined with hyphen. Same thing, sh space etl data load dot hql. Sorry, hql is triggered from the sh. So we run etl underscore job dim dot sh, because sh can run sh script only. This time it should run. Job is submitted. So this will take minimum 5 minutes because 7 stages are there. And after this line will compile all that 7 stages one by one. So one record is retrieved already here. Okay, so this is all done in 8:48 seconds. Time is more because multiple times insert operation we are running. 8:48 second, roughly 14 minutes. Okay. Now we'll validate the data first. Go to Hive table and run a query on this. Select star from customer dim main. Sorry, stage table first. Stage one. So only one result should be there. The machine is slow. Okay, so this result is only there, and this is what we're expecting. Select the star from customer dim main table. And inside this table, we have two results related to Rio. And you can see this is the old data because the flag is set as N here. And this is the new data with updated result. And this is set as Y. Now, when I run again one update query or insert query, so this table will delete this information because this is like one holder. Okay, this is just for time being. When I again start update or insert query, so that updated result and inserted result will store inside this table and previous data will be deleted. But in main table, they will maintain everything, all main, historical, inactive, active, all that result will be there. Now, how this operation is happening, eighth one, this is based on our script, Hive script. Here we'll open this HQL, vi, ETL data, load, and from first query, we are setting three properties: partition true, dynamic partition mode from strict to non-strict, then parallel is true. Parallel true means multiple core, multiple CPU will submit this task. Here I'm selecting my database, which is a FIU. Then I'm creating one temporary table, create temporary table. Okay, temporary table for only this transaction purpose. Once the transaction is completed, this table is automatically deleted. This is nowhere present. Create temporary table FIU. This is by the way my database name. FIU dot customer dim TMP. Okay, so customer dim TMP table will be created inside this database as select star from ETL schema. Again, this is a FIU. Customer dim limit 0. When you run this query, what will happen? Limit 0 means no result, right? Limit 0 means no result. So this is like you have one DDL available, data definition available for customer dimension main and you want same schema for customer dimension temp also. But you don't want any data. You want only schema. That's why you're running this query. So customer dimension main DDL, it will be created inside customer dimension TMP. The same DDL will be created here using the first query. Okay. Then in second, line number 27, we'll check this 27 to 30. Then in next class, we'll conclude this. Insert into, and here I have written the stage with a step. What we are doing here, load expired record from main to temp table. What do we mean by expired record? The previous data for Rio. Okay, the previous data for Rio, which was IMI 011. This is the old data now because this is what we updated. So we are considering this as a expired information. Record from main to temp table. So this result, this history result, we will store from main table to temporary table. And this is the query. Insert into FIU dot customer dimension temp. We are inserting in this table, and source table is select star from FIU dot main table where active flag is equal to n. If any value we have where active flag is n and effective to date is not null. Effective to date is not null means the account has been closed. If they find any data, they will write in the customer dimension main. Okay. After this second part, we will check on Thursday, and on Thursday we will conclude this historical data analysis project. Flow wise, we'll check. Any question is there, we can see on Thursday. Since look, this is a project, so it will take time for connection. Okay, you have to connect the data pipeline and you have to connect the flow. But still, if any question is coming, we can discuss it. Thursday we'll try to complete this project, and then from Monday we'll start our last project, which will be real-time data analysis on Scoop and Kafka. Sorry, Spark and Kafka.